Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of optimization. So as per the problem, when the rules of hockey were developed, the distance between the goalposts was designated to be 6 feet, slightly less than 2 meters. If Sidney Crosby is on the goal line 3 feet outside one of the goalposts, how far should he go out perpendicular to the goal line to maximize the angle in which he can shoot at the goal? So the first step is to understand the given diagram in the context of the situation described in the problem. Let's label the corner points in this diagram. Points A and B represent the goalposts. Line segment BC represents the goal line and point C represents Sydney's position 3 feet outside one of the goalposts. Now we have to find the value of x that will maximize theta. So in order to solve this problem, we should break up this diagram into two right angle triangles. So this is the bigger right angle triangle ACD, and the smaller right angle triangle is BCD. Side AC is 9 feet long. Side BC is 3 feet long. And we have to solve for x that will maximize theta. And theta can be shown in the triangle ACD. So we have to find the value of x that will maximize theta. And to analyze theta, we should use the tangent function because tangent function is an increasing function. So we are able to identify the x value at which the tangent of angle theta will maximize will also be the x value at which theta will be maximum. So there's a very important concept we need to understand and memorize. The next thing is that we should analyze angle theta in terms of angle ADC and angle BDC. So let's assume angle ADC is equal to M and angle BDC is equal to angle N. So we can write theta in terms of M and N as theta equals M minus N. So angle M is this full angle here and angle N is this smaller angle. Since we want to use the tan function to analyze theta, we can apply tangent function to both sides of this equation. Now we can use the angle difference identity for tan ratio. So we can rewrite tan of M minus N as so this is the angle difference identity for tan ratio. Now if we analyze the triangles ADC and BDC, tangent of angle M is equal to 9 over x. The formula for tan is Opposite over adjacent. Triangle ADC is a right angle triangle. So tan of angle M is equal to 9 over x. Similarly, tan of angle N is equal to 3 over x from triangle BDC. Now we can sub in these values in the identity. Now we can simplify this expression. So 9 over x minus 3 over x is equal to 6 over x. Now we have to multiply the fractions in the denominator, and 9 times 3 is 27. Next, we can simplify this expression by finding a common denominator in the denominator expression. So the denominator of 1 is 1, so the common denominator will be x squared. So we can rewrite this expression as now we can combine the fractions in the denominator. Next, we can write this expression as a division statement for these two fractions. Next, we can change this division statement into a multiplication statement. We should flip the second fraction. Now we can cancel out one of the x's. So this is the expression for tan theta. Next, we should find the derivative of this tan function and set the derivative equal to 0 to find the x values at which the tangent is horizontal. At peak points in the tan function, the tangent will be horizontal, and at those values, the slope of the tangent will be equal to 0, or the derivative will be equal to 0. Now, since this expression is a fraction, we can use quotient rule to find the derivative. So as per the quotient rule, we write the expression in the denominator times the derivative of the numerator expression. The derivative of 6x will be just 6 minus the numerator expression times the derivative of the denominator expression over the square of the denominator. Now we can set this derivative equal to 0. We can simplify the numerator expression. So we can distribute the 6 into the parentheses. And 27 times 6 is equal to 162 minus 12x squared. Now we can cross multiply the denominator, and we can combine like terms in the numerator. The 6x squared minus 12x squared is equal to minus 6x squared. Now we can solve for x by subtracting 162 from both sides. And now we can divide both sides by -6. So I get 27. And now we can apply square root to both sides. I get x equals almost 5.2. And the unit is feet. Now we can check if the angle value is maximum at x equals 5.2 feet, and for that we should use the first derivative test. So we should check the sine of the slope of the tangent to this tan function on the left and the right hand side of this x value. So we can use the number line method. So we should use a test value on the left side of this value, and it can be 5, and another value on the right side of this value, which can be 5.5. Now we can sub in these test values in the derivative function, which is let's start with the test value x equals 5. So we should sub in x as 5 in this derivative expression. The denominator expression will have a positive value, and in the numerator, -6 times 5 squared plus 162 gives us a positive value. That means the first derivative has a positive value on the left side of 5.2. That means tangent has a positive slope, so the function is increasing. Now we can use the test value 5.5. The denominator will give us a positive value because of the square on the expression, and in the numerator we have to do -6 times 5.5 squared plus 162, which is equal to -19.5. So the overall value of this expression will be negative. That means the slope of the tangent is negative to the right side of x equals 5.2 feet. The function is decreasing on the right side. That means at x equals 5.2 feet, the value of theta is maximum. So therefore, we can conclude so this should be the final answer for this problem. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.